Hello guys, let me introduce myself. My name is IJTIMOIY. I am teacher of biological chemistry. Today we will talk about common pathways of catabolism and biological oxidation. The main sign of life is a continuous exchange of matter and energy. Nutrients and oxygen must enter the body and metabolic products will be released. Consuming human food is used to build its macromolecules and as energy. Metabolism is the exchange of substance at the cellular level, including chemical processes occurring from the moment food enters the cell to the formation of end products of metabolism. There are two aspects of metabolism is anabolism and catabolism. During catabolism, organic matter eventually breaks down into carbon dioxide and water. The process of catabolism is exergonic. Anabolism is the transformation of simpler substances into more complex ones that serve as structural and functional components of the cell, such as coenzyme, hormones, proteins, nucleic acid. Many anabolism reactions are endergonic. Stage of metabolism as a catabolism. Stage first, specific degradation of macromolecules, proteins, carbohydrates, lipids to monomers. Stage 2, specific amino acids, fatty acids, and glucose are oxidized to a common metabolite, acetyl coenzyme A. And stage 3 is non-specific. Acetyl coenzyme A is oxidized in the citric acid cycle to diacidic carbon and water. There are two ways of catabolism: specific pathways of catabolism characteristic of individual classes of substance, and general path of catabolism. The common pathway of catabolism includes the oxidative decarboxylation of PVC and the Strata cycle. It's in the general pathway of catabolism that the bulk of the primary hydrogen donors for the respiratory chain are formed. Oxidative decarboxylation of pyruvate produced acetyl-CoA, produced NAD and carbon dioxide. The first step is pyruvate dehydrogenase complex. It means converting pyruvate to acetyl coenzyme A. Pyruvate dehydrogenase complex is a multi-enzyme complex that consists of 3 enzymes and 5 coenzymes. First enzyme is pyruvate dehydrogenase. Second enzyme is the hydrolipoyl acetyl transferase. Third enzyme is the hydrolipoyl dehydrogenase. Coenzymes are TPP, thiamine pyrophosphate, lipoamide, sulfhydroxyl-CoA, and FAD and NAD. Composition of the pyruvate dehydrogenase complex. Pyruvate dehydrogenase complex comprises 3 enzymes and 5 coenzymes. Molecular weight 9. The complex consists of 30 tetramer molecules. "60 trans-acetylase molecules and 10 flavoprotein molecules. Enzymes of pyruvate dehydrogenase complex: pyruvate lipoatoxydoreductase, lipoacetyl transferase, the hydrolipoyl dehydrogenase. And now we need to talk about the Krebs cycle. Function of the tricarboxylic acid cycle is metabolic integration. The cycle is amphibolic, catabolic, and anabolic at the same time. Formation of energy in the form of GDP, ATP. Formation of reducing equivalents in the form of NADH and FADH2. Regulation of the tricarboxylic acid cycle. Stability measurement of the tricarboxylic acid cycle. 2 carbon atoms enter the cycle as acetyl-CoA. 11 ATP for oxidative phosphorylation. 1 ATP is formed directly in the cycle. 1 acetyl coenzyme generates approximately 12 ATP molecules. Transliterase is a regulated enzyme inhibited by ATP and NADH. There are 2 types of isostartrate dehydrogenase. The coenzyme is NAD or NADP. NAD isostartrate dehydrogenase is an allosteric enzyme activated by ADP. It comes in monomeric and dimeric forms. The dimeric form is more active than the monomeric one. Alpha-ketoglutarate dehydrogenase complex is a multi-enzyme system, molar weight 2.1. Humerase, MDH, regulation of the Krebs cycle. The regulation of the Krebs cycle is carried out by 2 groups of substances. Metabolites oxalate, a competitive inhibitor of STH, acetyl-CoA, activator of pyruvate decarboxylase, citrate, activator of acyl coenzyme carboxylase, adenyl nucleotides. The activity of citrate synthase depends on NADH2 ATP. Isocitrate dehydrogenase is activated under the influence of NAD ADP. And now we need to talk about anabolic function of the Krebs cycle. Alpha-ketoglutarate can form a glutamate precursor of proline, ornithine, citrulline, arginine, and other substances. Oxaloacetate, glucose, asparagine, pyrimidine nucleotides, some amino acids. So, succinyl-CoA, fumarate, aromatic amino acids, acetyl-CoA, fatty acid, cholesterol, acetylcholine, acetyl-glucose amine. Hypoenergic conditions: elementary, starvation, hypovitaminosis, hypoxic, associated with impaired oxygen supply to the blood. Exogenous hypoxia pulmonary, respiratory hypoxia, associated with impaired oxygen transport in tissues. Hemodynamic hypoxia, hemoglobin hypoxia, and mitochondrial associated with impaired use of oxygen in cells. Thank you guys. See you.